Hello, this is not your chem tutor, and in this video, I will teach you how to solve the density of face-centered cubic or FCC unit cell. I have included practice questions for you to be familiar with the problems involving this topic. So the questions get harder as we go along the way. So let's proceed to the formula. In solving the density of a unit cell, it is equal to Z times MW divided by A cubed NA. Z stands for the number of atoms per unit cell, and it depends on the structure of the unit cell. It's different for FCC, BCC, simple cubic, etc. So for FCC, Z is always equal to 4. So there are 4 atoms per unit cell for FCC. MW stands for molecular weight or the molar mass, and the unit is grams per mole. A is the edge length of the unit cell, and the formula for edge length is also dependent on the structure of the unit cell. So it's different for FCC, for BCC, etc. So for FCC, you can compute the edge length using this formula. A is equal to 4R divided by square root of 2. R is the atomic radius or the radius of the atom. I made a separate video on solving for edge length. You can actually check the video using the link on the description box. And we have NA. NA stands for Avogadro's number, 6.022 times 10 raised to 23 per mole. Let's answer the first question. Silver crystallizes in an FCC structure. The edge length of the unit cell is 4.088 times 10 raised to negative 8 centimeters. What is the density of silver in grams per cubic centimeters? So we will use our formula for density. Density is equal to Z. I told you before that Z for FCC is 4 times molecular weight. The molecular weight of silver is 107.9 grams per mole. Divided by A raised to 3. So A is the edge length, and we are given the edge length 4.088 times 10 raised to negative 8 centimeters. You need to raise that to 3 or cube it, times Avogadro's number, 6.022 times 10 raised to 23 per mole. So let's see how the units will cancel out. Moles will cancel. So your unit for density would be grams on top, and on the bottom you have cm cube or cubic centimeters. So gram per cubic centimeter. Now grab your calculator and type the entire equation. 4 times 107.9 divided by the cube of 4.088 times 10 raised to negative 8 times the Avogadro's number, 6.022 times 10 raised to 23, and you will get the answer 10.49 grams per cubic centimeter. So this will be the density of silver. For question number 2, you can actually pause the video, try to answer this on your own, and then get back if you have the answer. Nickel crystallizes in an FCC structure. The atomic radius of nickel is 125 picometers. What is the density of nickel in grams per cubic centimeters? Take note that 1 picometer is equivalent to 1 times 10 raised to negative 10 centimeters. So we are given the atomic radius of nickel, 125 picometers. So why are we given the atomic radius? Because we need that to solve for the edge length. So we use the formula edge length is equal to 4 times the atomic radius, 125 picometers divided by square root of 2. And if you solve this using your calculator, 4 times 125 divided by square root of 2, this is equal to 353.55 picometers. However, we need to convert picometers to centimeters because the question is asking for the density in grams per cubic centimeters. In order to do that, we use the conversion given in the problem. 1 picometer is equivalent to 1 times 10 raised to negative 10 centimeters. So picometers will cancel and the unit becomes centimeters. So 353.55 times 1 times 10 raised to negative 10, this is equal to 3.5355 times 10 raised to negative 8 centimeters. So this is our edge length. Now that we have the edge length, we can use the formula for density. So density is equal to Z, which is 4 for FCC, times molecular weight, we have 58.69 grams per mole, divided by the edge length, 3.5355 times 10 raised to negative 8 centimeters raised to 3 times Avogadro's number 6.022 times 10 raised to 23 per mole. Again, moles will cancel, so the unit for density would be grams on top over cubic centimeters. So grams per cubic centimeters. And if you solve this in your calculator, you will get the density of nickel, which is equal to 8.82 grams per cubic centimeters. And this is the answer to the question. Question 3, again, you can try solving this on your own, so you can pause the video and get back if you have an answer. Lead, which crystallizes in an FCC structure, has a density of 11.29 grams per cubic centimeters. What is the atomic radius of lead in nanometers? Note that 1 nanometer is equal to 1 times 10 raised to negative 7 centimeters. There are actually 2 steps in solving this problem, and step number 1 is to solve for the edge length, or A. So we still use this formula, density is equal to Z times MW divided by A cubed NA. So what we should do is to rearrange this equation to solve for A. So how do you do that? You multiply both sides of the equation by A cubed, so that A cubed will cancel on the right side. So your equation becomes A cubed times density is equal to Z times MW divided by NA. Then, you divide both sides of the equation by density. So density will cancel on the left side, So your equation becomes a cubed is equal to z times mw divided by Na density. And to solve for a, you need to get the cube root of both sides. So cube root of a cube is a. So a is equal to the cube root of z times mw divided by Na times density. Now we can solve for a. A is equal to cube root of z. For FCC, z is equal to 4 times the molecular weight. We are given 207.2 grams per mole. Divided by Avogadro's number, 6.022 times 10 raised to 23 per mole times the density, which is 11.29 grams per cubic centimeters. And if you solve this in your calculator, you will get the value of A, which is equal to 4.958 times 10 raised to negative 8, and the unit would be centimeters. So why centimeters? Let's check. Moles will cancel, grams will cancel, we have cm cube left, and you get the cube root of cm cube, so the unit would be centimeters. So this is our A. Now that we have A, the second step is to solve for R, or the radius. So we will use the second formula. A is equal to 4R divided by square root of 2. We already got A. That's 4.958 times 10 raised to negative 8 centimeters is equal to 4R divided by square root of 2. So to solve for R, multiply both sides of the equation by square root of 2. So square root of 2 will cancel on the right side. So your equation becomes 4R is equal to square root of 2 times 4.958 times 10 raised to negative 8 centimeters. Divide both sides by 4. So 4 will cancel on the right side. So your radius R is equal to square root of 2 times 4.958 times 10 raised to negative 8 centimeters divided by 4. This is equal to 1.753 times 10 raised to negative 8 centimeters. But the question is asking for the radius in nanometers. So we will convert centimeters to nanometers. So we have 1.753 times 10 raised to negative 8 centimeters. According to the conversion, 1 nanometer is equivalent to 1 times 10 raised to negative 7 centimeters. So centimeters will cancel and the final unit would be nanometers. So in nanometers, this is equal to 0.175 nanometers. And this is the final answer to the question. 0.1753 nanometers. The last question is question number 4. Again, you can pause this video and get back if you have an answer. An element that crystallizes in an FCC structure has a density of 21.45 grams per cubic centimeters. The atomic radius of the element is 1.387 angstrom. What is the molecular weight of the element? And what is the identity of the element? This question also has 2 steps. The first step is to solve for the edge length. Solve for A using this formula. A is equal to 4 times the radius, 1.387 angstrom, divided by square root of 2. And if you solve this in your calculator, this is equal to 3.923 angstrom. Then we need to convert angstrom to centimeters. Why? Because if you look at the given density, it is in gram per cubic centimeters. So 3.923 angstrom, we use the conversion given to us. 1 angstrom is equivalent to 1 times 10 raised to negative 8 centimeters. So angstrom cancels out and the unit becomes centimeters. And this is equal to 3.923 times 10 raised to negative 8 centimeters. So that is our edge length, or A. Second step would be to solve for the molecular weight of the element. So how do we do that? We use this formula. Density is equal to Z times mW divided by A cubed NA. To solve for mW, or the molecular weight, we need to rearrange the equation. So how do you do that? First, you multiply both sides of the equation by A cubed NA. So A cubed NA cancels on the right side. So your equation becomes Z times molecular weight on the left side is equal to A cubed NA times density on the right side. Then, divide both sides by Z. So Z cancels on the right side. So the formula for mW, or molecular weight, is A cubed times NA times density divided by Z. Now that we have the formula for molecular weight, we can substitute the actual numbers. So molecular weight is equal to A raised to 3. So the value of A, we computed it in step 1. 3.923 times 10 raised to negative 8 centimeters cubed times Avogadro's number 6.022 times 10 raised to 23 per mole times density in the problem is 21.45 grams per cubic centimeters all over Z, which is 4 for FCC. And let's see how the units will cancel. Cm cube will cancel. So the unit for molar mass or molecular weight would be grams per mole. And if you solve this in your calculator, you will get the molecular weight equal to 195 grams per mole. So this is the molecular weight of the element, and this is the answer to the first question. The second question is asking for the identity of the element. If you check your periodic table, which element has a molar mass or molecular weight closest to 195 grams per mole? The answer would be platinum or PT. So the identity of the element is platinum.